And you're like, wait, hold on, why are there two equations? Because it's a system. A system is a collection of equations that is solved simultaneously, which means at the same time. So we're actually going to be solving both of these at the exact same time. Not one, but both. Now, since we have two equations, that means we should have how many answers? Two answers. You're going to have two answers. When you solve a system, such as this one above, you will be solving for both x and y. We will end up with two answers. One answer for x, one answer for y. There's only one combination of x and y in the entire universe that will solve this system, which means by solving, I mean when you substitute an x and y, you'll get two true statements. We'll get to that down here. Your answer will always be in the form of a coordinate pair. Later on in the chapter, when we solve systems of equations by graphing, you're going to see where all of this goes. Every system of equation solution is a coordinate pair because it's actually the point where if we graphed both of these equations, where the two lines overlap each other. Now, that's later on when graphing. That's lesson 3. We'll get there and you'll understand more about it. Right now, let's just focus on how we turn this mess into a coordinate pair. Now, you will get a coordinate pair when you solve it. You will. And then you can take that, just like we could with a normal solution, substitute it back in, and we should end up with, if it was a regular equation, we'd end up with a true statement if we substituted our answer back in. And in systems of equations, if you substitute whatever your answer is, in this case, this would be the answer to this system. If you substitute it back in here, you're going to get two true statements. You should get a true statement for the top equation, a true statement for the bottom equation. But what does that mean? That means, and we will solve these in a couple minutes, that means that if we were to solve this system using the methods that I'm going to show you a little later on, we would get this coordinate pair. How do I check to see if this coordinate pair is actually the real solution? I substitute 4 and 5 back into both equations. What does 4 correspond to, an x value or a y value? X value. What does 5 correspond to? Y value. So we would take this coordinate pair, we would substitute it into both equations. So what I did is I took these equations here, they're down here now. And I replace the x and y with a 4 and a 5, and a 4 and a 5, to see if I get two true statements. So I substitute in, I multiply and add. On the top equation, 4 times 4 is 16, 3 times 5 is 15. What's 16 plus 15? 31. Does 31 equal 31? Yes, that's your true statement. I check it on the bottom. I substitute in, I get negative 16 plus 40. If I combine those, I get 24 equals 24. So when I substitute my solution in, I get two true statements. You should never get any system of equation wrong, because you can always go back and substitute in your answers to check your work. Just like a regular equation. You can always take your solution, you substitute it back in, and see if you have the right answer. But the real question is, how do we turn this into this? In order to understand that, there's a couple of things you have to know before we can ever solve this.